Okay, Year 9, welcome to your tutorial on working out the equation of a straight line. So, let's begin. A linear relationship is a way of expressing how one thing is related to another. Or, for example, at the moment, how x is related to y. That's what we've been looking at. So far, we've learnt how to express that relationship, how x is related to y, in a variety of different forms. We've drawn Cartesian planes that have an x and a y axis. We've then dotted plots and drawn lines and said, okay, this is the linear relationship. This is what it looks like. We've had values tables which map out for us, this is how x is related to y. And we've also looked at rules and actual equations, so y equals something x minus something. We've looked a lot at these relationships and we've looked at a lot of different ways that we can express these relationships. Another thing we already know is different ideas that are related to, okay, so yep, x is related to y, and if I draw a line, which is essentially a linear relationship, I know things about that and I know key things to do with that. Things that I've learnt so far is the idea of intercepts. So that line will intercept an axis, both an x and a y axis at a certain point, depending on what the relationship is. I've also learnt that the steepness of the line can be expressed as this thing that I call a gradient, and I can calculate that in a certain way. So I know all of this information about these linear relationships, and I know a variety of forms that I can express that linear relationship in. Today, what we are going to do is we are going to bring that all together. We are going to draw on all the information that we've known and we're going to bring it all together. The simplest way to represent a linear relationship is in the form of an equation. And I've just jotted some down here. These are common ones that you would have seen straight from our very first lesson. Y equals 2x subtract 4. So we're saying when I double x and I subtract 4, I will get my y value. So no matter what x is at any given point, if I double it and then subtract 4, that's what my y will be, and that's what that relationship is here. For this, that was for this one. For this one, for example, I'm saying whatever x is, triple it and you will get the y value. This one's saying 3x plus 9 will give you y. They're all talking about how x is related to y. Now I'm going to blow your minds a bit because I'm going to show you how 1, 2, 3, 4, and 5 are all exactly the same equation. Let's have a look. Okay, the funny thing is that all of these equations actually follow a same pattern, and this is what we call the equation of a straight line. Y equals mx plus b. They don't always follow this exact order, but they all have this same structure or same pattern. They all follow this same structure. Now, okay, in this equation, y equals mx plus b, m is my gradient, and b is where my line hits the y-axis or my y-intercept. So, y equals something x, that something is my gradient, plus or minus something is where my line intercepts with the y-axis. So that's what you have to understand. Y equals mx plus b is the equation of a straight line. M is my gradient, which I've already learnt about before. It means that's how steep my line is. And b is my y-intercept. Okay, let's go back and have a look at some of those equations that were just on the previous screen. And let's see how they follow this formula equals mx plus b. So, let's go back. Y equals mx plus b. If we look at this equation here, what this is saying, y equals mx plus b. What this is saying is, let's see how it slots in, y equals 2x. Now, here I have plus b, okay? That means that b is my y-intercept. Instead of being a positive number, like plus b, it's actually negative 4. So what this equation is saying is that my gradient for this line is 2, and my y-intercept is, my line is cutting my y-axis at negative 4. Let's have a look at this example down here, down the bottom. Y equals x plus 5. Now, there's no number in front of the x. When there's no number in front of the x, what does that mean again? What does that x represent? Oh, okay. I remember now. It means that there's 1. Okay, so if I see this equation y equals x plus 5, following this idea that I've just learned, that all straight lines follow the similar formula, this is trying to say to me that my gradient is 1 and that my line is intercepting my y-axis at 5. All right, that's not too bad. That also follows the same pattern. Isn't that interesting? Let's go back and have a look at this top one up in the corner. Okay, let's have a look at this one over here. Y equals 3x plus 9. That's saying my gradient is 3 and that my line is hitting the y-axis at 9. So my line is intercepting my y-axis at 9. Isn't that interesting? It follows the pattern as well. Let's have a look at this one down here, okay? What this is saying is that my gradient is -4, and you came across some gradients that were negative yesterday, okay? And that my line is intercepting my y-axis at -5, okay? Let's have a look. Now, this one in the middle, isn't that interesting? Sorry, that one follows the same pattern as well. This one in the middle, y equals 3x. Now, this doesn't appear to follow this equation of a straight line pattern. It doesn't appear to be doing that. But let's have a look. Y equals something x plus b. B would be my y-intercept. Now, my gradient for this line is clearly 3. Following this idea from the formula, I know that my gradient for this line will be 3. Where would my line be hitting the x-axis? There's nothing afterwards. What would be the only circumstance where I wouldn't have to include the plus or minus? What would be the only circumstance where I wouldn't have to include them, or it wouldn't be necessary? Oh, of course, if I plus 0 or if I subtracted 0. So if I had 3x subtract 0, it'd be almost unnecessary to have that subtract 0, wouldn't it? So what's actually going on here, guys, with this equation is my line is intercepting the x-axis at 0. But because I don't really need to say plus 0 or minus 0, I don't actually need to include it. So what I found out by discovery and looking at each equation is every single equation on this page follows the rule and follows the pattern of y equals mx plus b. All I need to remember with this equation is, okay, yep, sure, every linear relationship may follow this equation, but whatever comes before the x is my gradient. Whatever is plus or minus to the x is my y-intercept, okay? They're the main things that I need to remember. So how are we actually going to use these? Well, let's have a look. If I'm asked to write the equation of a line if m equals 3 and b equals 4. Now, we assume that m is my gradient. M is my gradient. Okay, I'm going to write gradient, and b is my y-intercept, okay? I can actually write a formula. I know y equals mx plus b is the basic formula that works, okay? And if I substitute into that formula, y equals, now this question told me if my gradient is 3, how would I write the formula? Okay, well, I'd write 3x, and the question always tells me, also tells me why y-intercept is 4, so where would I put that? Oh, of course, I put it here. What we're doing here and what you're being asked to know is, if I know my gradient and I know my y-intercept, can I write a formula? All you have to do is follow the structure of y equals mx plus b and simply substitute into that. Now I've got another example. Okay, if m, or my gradient, is a half and b is -3, what would that look like? Again, it follows the same structure, y equals mx plus b, okay, where b is my y-intercept and m is my gradient. Now I've said my gradient is a half, so it's a half of x. Okay, I can write that. It doesn't have to be a whole number. And it says my y-intercept is -3. So instead of putting plus b, it's going to be -3. That's it, guys. That's how I write a formula or an equation with this pieces of information just here. Okay, always follow that structure, y equals mx plus b. So you may be required to write the formula, or you may be required to interpret. Let's have a look what it would look like to interpret. Okay, so it says identify the gradient and the y-intercept of the following lines. This time we're doing the opposite. This time we've been given the equation and we're asked to identify what's my gradient and where does my line hit the x-axis. So I know with y equals mx plus b, whatever number or numeral comes before the x is my gradient. I also have to pay attention to if it's a positive or a negative. So this says y equals positive 2x, okay? So my gradient, or m, will be 2. My y-intercept, okay, I'm just going to write that as y-int. My y-intercept will be whatever else is followed in the equation. So this says y equals 2x subtract 4, which must mean that my line is hitting my x-axis at negative 4. B is a little bit different. What I've done for you guys is I've flipped them around, okay? It's still the same way of saying it. I've just reversed the order. This time I put the y-intercept first, and I put the gradient second in order. You may be asked it like this. This is why I have done it like this. So my gradient is whatever number or numeral comes before the x. In this case, it's 2/3. But it's not just 2/3, it's negative 2/3, okay? So you need to pay attention to the fact that it's negative 2/3. That's my gradient. And you would have been, when we were doing that work from yesterday, you would have been looking at some gradients that did have negatives and were fractions, okay? So my gradient is negative 2/3. I know this because this is what's directly before the x. My y-intercept, on the other hand, is 8. So that means that my line hits my y-axis at 8. And that's it, guys. Understanding that, yeah, why the rules and the equations look different, they're all following this same structure. Y equals mx plus b. M is my gradient, it's whatever comes before x. My y-intercept is the other number in the equation, either positive or negative. And that's it, guys. That's the equation of a straight line.